So we go from talking about nails to talking about clovers. Three-leaf clover. How many leaves are there on 14 clovers? How do you solve that? Well, you have to know how many leaves are on one clover, right? So there are 3 leaves on one clover, and if we've got 14 clovers, we're going to multiply by 3 leaves per 1 clover and come up with the answer of 42. We do a similar thing with compounds. If I ask you how many legs are on 2 spiders, what's the answer? 16, because 1 spider has 8 legs, so 2 spiders must have 16 legs. Okay, so there are 8 people in my family. If we have 8 chairs around the table, how many legs are there? Chair legs. I'm not trying to make a joke. It'd be 4 times 8, there'd be 32 chair legs, right? So if we have 5 water molecules, how many hydrogen atoms do we have? 10. The math is the same. Okay? It's just that molecules are something we're not used to thinking about. But we are used to thinking about everyday objects that have different numbers of parts, right? A bicycle has 2 wheels. It has 1 set of handlebars, 1 seat. It's got 2 pedals, right? Maybe it has 10 gears or whatever. And so it has different parts. And chemical formulas have different parts as well. In 1 water molecule, there's 2 hydrogens and 1 oxygen. And that relationship can be used to help us figure out how many atoms are in a certain amount of water. So find the number of moles of carbon in 2.3 moles of lead carbonate. Well, how many moles of carbon are in 1 mole of lead carbonate? 2 carbons. Yeah. I just have to pull up a color that we can see because black's not working for me right now. So in 1 mole of lead carbonate, there are 2 moles of carbon. Because in the formula, in each of these formulas, we have 1 lead, 2 carbons, and 6 oxygens. So if we had a dozen of them, we would have 2 dozen carbon atoms. If we have a mole of them, we have 2 moles of carbon atoms. Does that make sense? I can repeat that. In one formula, we've got 2 carbon atoms. So in a mole of, sorry, go with the dozen first. In a dozen of these, we would have 2 dozens. And in a mole, we'd have 2 moles. So if one person is not quite sure on that, that means that like half the rest of the class isn't right sure. So let's talk about the clovers again. So there's a clover. 1 clover has 3 leaves. If I had a dozen clovers, how many dozen leaves? 3, right? 3 dozen. Why does it work out that way? Because a dozen is just a certain number. So it's like I'm taking this side of the equation and multiplying by 12, and this side and multiplying by 12, 12 being a dozen. So 1 clover has 3 leaves. A dozen clovers would have 3 dozen leaves. You follow that? Is that okay? So in chemistry, we don't use dozen because it's not big enough to be helpful for us. We use the chemist's dozen, which is just a really big number. So a mole of clover would have 3 moles of leaves. no matter what unit you stick in here, what counting unit you stick in there, there's always 3 times as many leaves as there are clover, little whatevers they are, clovers, just call them clovers. Does that make sense? When we look at this formula, no matter how much of it we have, there are twice as many carbon atoms as units of this, because each unit has 2 carbons in it. If we have a bicycle, it's got 2 wheels. If we have a dozen bicycles, we're going to have twice as many wheels. No matter what number of bicycles we have, it'll be twice as many. The nice thing about erasing like that is it doesn't leave all those silly eraser crumbs all over the place. So looking at the formula, there's 2 carbons for every formula. And so we've got this 1:2 ratio. So if we have 2.3 moles of the lead carbonate, lead 2 carbonate, and we want to know how many moles of carbon are in that, we have 2 moles of carbon for every 1 mole of lead carbonate. So we take 2.3 and multiply by 2 and we get 4.6 moles of carbon. We can't do this with grams, but we can do it with moles or dozens, because those are counting units. The formula relates numbers of atoms to numbers of molecules. It's all about the particles. It's not having to do with the mass. Any questions? So let's look at this slide first. So we get relationships from the chemical formula. 1 mole of carbon tetrachloride contains 4 moles of chlorine. We're getting this 4 from the formula. In this molecule, there's 1 carbon atom and there's 4 chlorines. Here's an illustration of that molecule. In one of those, there's 4 little green balls. So if we want to know the number of green balls, we're going to use a 4:1 ratio. So let's go back and do this problem. Find the mass of aluminum in 19 grams of aluminum chloride. This formula tells us that there's 1 aluminum atom in every 1 molecule of AlCl3. That's what the formula means. Well, numbers of atoms and molecules are a little difficult to work with, but we can say that there's, based on that 1 mole of aluminum is equal to 1 mole of AlCl3. In each molecule, if you will, you've got 1 atom of aluminum. So if you have a dozen of these, you're going to have a dozen aluminum atoms. If you have a mole of these, you're going to have a mole of aluminum atoms. We get that out of the formula. That's relating particles. This question, though, is asking for the mass of aluminum, and it's giving us a mass of aluminum chloride. We can't just apply this ratio to the mass, because the mass of aluminum and the mass of aluminum chloride particles are different. So we have to take the masses and go to a particle unit, then look at the ratio and go back to a mass. So 19 grams of AlCl3. We want to convert that into moles of AlCl3. And to do that, we're going to need the molar mass. So we're going to take this formula We're going to calculate the mass of 1 mole of that. 1 mole of that will equal the mass of aluminum. So I've used enough today, I should remember it, 26.98. And the mass of 3 chlorines, 3 times 35.45. And I think that was 133.33. But I'm going to double check. Yes. 133.33 grams. So 1 mole of aluminum chloride weighs 133.33 grams. That's a skill we learned today, calculating the mass of a mole of a compound. So that allows us to take this mass of silver chloride that we're given and convert it into moles of silver chloride. These units cancel out. So now we have moles of aluminum chloride, and what we just figured out here is that if we have 1 mole of aluminum chloride, we have 1 mole of aluminum atoms. So if we're trying to be thorough and write everything out, we can write it out like this: 1 mole of aluminum per 1 mole of aluminum chloride. And those units cancel out. Now we're left with moles of aluminum, but the question wants mass of aluminum. So now we need to use the molar mass of aluminum, which is 26.98 grams for every 1 mole. So we start with 19, and we divide by 133.33. That gives us the number of moles of the compound, which is equal to the number of moles of aluminum because of that 1-to-1 ratio. And then we're going to multiply by 26.98 to find out what the mass of the aluminum is. And that should have, I guess, 2 sig figs because of that 19 that we started with, 3.8 grams of aluminum. So what this is telling us is if you have a 19-gram sample of a compound aluminum chloride, 3.8 grams of that mass is from the aluminum. What's making up the rest of the mass? The chlorine. Okay, because the mass of the compound is the mass of the chlorine plus the mass of the aluminum. Any questions? This is kind of a weird, this is a good to know problem, but it's not an essential kind of problem. If you practice on the other ones, this will start to make more sense. This is one that's kind of hard to absorb the same day that you learned all the other stuff.